At this step, we will consider the standard system parameters of the family. We are already familiar with some of them. The most important family parameter is its category. It is set through the Family Category and Parameters window. We already know that other main family parameters are listed in the same window. This list also partially depends on the category. For example, if we specify Duct Accessories category, we will see that the set of family parameters changes. I will press the Cancel button. Also, family parameters are displayed in the Properties panel, unless, of course, nothing is selected in the model space. Let's consider the doors category parameters in order. The first one is the host. We know that the door we are creating is inserted into the wall, so the wall is the host for our family. Actually, we can create doors without any hosts. If we select the metric generic model template and set the doors category in the open file, we can also create door families with any other host. We have chosen a family template with the wall as its host because this is the most common case for doors. The next two parameters are the Omni class number and Omni class title. They are responsible for the fact that our product belongs to the position in the Omni class classifier. If we click on the Omni class number parameter value column, a button with three dots will appear. By clicking on this button, we will open the classifier page related specifically to the doors. However, we can switch to the other pages as well. We have the opportunity to select a position in the classifier. The selected data will be written into the parameters. In the future, we will be able to use this data to sort, filter, or select model objects in the various lists, including specifications. We also can assign additional classifier number to the door using special parameter in Family Types window. In the Identity Data group, by default, this parameter uses uniformat classification, but we can change it using the Manage tab, Additional Settings, Assembly Code. And here we can choose a classifier file by the Browse command. The parameters in the other group are responsible for the behavior of our family. The first one, always vertical, is responsible for the vertical placement of the family, even if its instances are installed on the inclined host. However, this is almost not applicable for doors. The tooltip assistance gives away a better example with a tree placed on a hill slope, and it can be set either vertically or perpendicular to the slope depending on the always vertical parameter value. The next parameter, cut with voids when loaded. If there is a void form that doesn't cut anything in the family itself, then, in the case if the cut with voids when loaded parameter is set, it will automatically cut voids from other objects when loaded into the project. However, it will cut voids not from every object, but from family instances sorting categories. There is a list of such categories in the tooltip assistance. The following parameter is shared. It makes sense to include it only for nested families. It allows us to consider a nested family in the project as a separate object. That is, we can form a separate line in the schedule for it. We can select it in the model independently of the parent family using the Tab key, and we can also separately tag it. If the shared parameter is turned off for a nested family, as well as for all our nested families, then They will be just constructing parts of the parent, and we will not be able to work with them directly in the project. It is also worth noting that it is better to turn this parameter on before loading the nested family into the parent, of course if it's necessary, since Revit will not be able to replace the family version without the shared checkbox with the one with this checkbox. You will have to delete the nested family from the parent and only after that load the new version. That means you will have to align the family instance and match the parameters again. The last parameter, called room calculation point, is responsible for the room our family will belong to. Rooms are special Revit objects placed on floor plans. They automatically fill in the areas inside the walls and between the floors. They are in fact three-dimensional, sort of like extrusion element, formed around the outline of the enclosed space. All the objects inside of this space are matched to the rooms, as well as the objects attached to them, such as walls, doors, and windows. If I go to the floor plan and turn this parameter on, I will see this symbol. The door can be matched to two rooms at once, the starting point and the one where it leads. Now the arrows show us that we are going from this room to this one. You can move these arrows. That is, I can install them in a quite tricky way. But I cannot place them both on the same door side. If you don't include the parameter on purpose, the family instances will still be matched to the rooms, but exactly in the position where the symbol is located by default. There is only one calculation point in the families of equipment, furniture, and so on, since these families don't lead from one room to another. They are simply located in room. In general, if the objects belong to a particular room, it allows us to count them in the schedules, not just for the entire project, but also for each room separately. If you want to know how many chairs there are in rooms with their classroom name, then you can find this out. So, we have considered all the system parameters of the family. Let's add another custom family parameter that we will write the wall width in. This parameter can be useful in case if we want to change any geometric object within the family by formula depending on the wall width. We need another reference plane along the interior face of the wall. We already have such a plane for the exterior one. It is snapped through a dimension with a value of 0 mm to the wall face. We need to snap this plane to the wall face too. I will set the value to 0 mm and close the lock. The plane is tied to the wall. Now I will set the dimension between the reference planes on the wall faces. And try to assign a parameter to it. I'll call this parameter as wall width. Note that the type instance switch is not active. It is in the instance position, and the reporting parameter checkbox is enabled additionally. In brackets, it is specified, can be used to extract value from a geometric condition and report it in a formula or as a schedule parameter. In fact, The reporting parameter reads the situation from the model. In our case, it will control the wall the door is inserted in, read its width, and show its value. All the other geometric-related parameters we created, on the contrary, change this geometry and don't read the data from it. For example, if we change the height parameter value, our family will change the opening height, but the reporting parameters value cannot be changed directly. They just show us something, and they change when there is a change of geometry due to the reason not related to them. I will move this parameter to the Analysis Results group. Click OK. It makes no sense to assign reporting parameters to the dimensions not related to the host elements in the family. They simply will not work in such a situation. The host elements are the objects strictly defined as basis ones within a family. We usually start building another geometry in the family by linking to them. We can say that these elements can be found in the template we created the family from by default. Actually, this is not completely true. For example, we created this reference plane ourselves, but we tied it to the wall face, which is a host element. Revit realized that this dimension is actually tied to the hosts. The reporting parameter will work in such case. You can try to upload this family to the project and check how this parameter will read wall width for door instances. Let's save our family.